B5, the quadratic equation. Here we're interested in an equation y equals ax squared plus bx plus c equals 0. And we would like to solve that for x. This is what we mean by the quadratic equation and its associated formula for finding the solution. There'll be two solutions. Since the x is squared, when you have a situation with x squared, you're going to get two solutions. If x were cubed, in general, you'd have three solutions. When you have x to the first power, y equals mx plus b, it's very easy to find the one solution. You subtract b from both sides of the equation. Y minus b is mx. And then you divide both sides by m. In high school, we used to have a little shorthand notation. S for subtraction, subtract b from both sides, and then we're going to divide by the m. And the answer is x equals y minus b over m. To make our analogy better, we should set y equal to 0 in the linear case, and then we will have x is equal to minus b over m. Now, in the notes, I'm going to call this section the quadratic formula because really we want to find the formula that gives us the solution when y is equal to 0, and we're going to find that in general there are two solutions for the quadratic equation. Now this one's not so easy, but we're going to solve it and find a general formula. So we start with x squared plus bx plus c equals 0. Now I'm going to divide both sides of the equation by a. X squared plus b over a x plus c over a equals 0. Now it would be nice here if we had a complete square, something like x plus a capital A squared equals something with constants on the other side. I'll write down CONST, say constants. Then we could take the square root of this and solve for x. So we would like to have a complete square, so we say we're going to complete the square. So to complete the square, if we had a and x, the quantity squared, we have x squared plus 2xa plus a squared. So what is this a that we're interested in? If this is what we have b over a times x. So that means the b over little a is equal to 2 times big A, which means that our big A is equal to little b over 2 little a. But we don't have this a squared thing here. You need to have the a squared so that it works. So here's what we're going to do. The a squared is b squared over 4 little a squared. So we're going to put it there and then subtract it. So we can do that. We don't change anything. So we have x squared plus b over little a times x, and then we're going to add it, plus b squared over 4a squared. Then we're going to subtract it, or we could just simply add it to both sides of the equation. So I'm going to prefer to do that. And I'm going to also take this c over a and bring it over to the other side. So it would be have a minus sign there. So this would be minus c over a by taking the c over a to the other side and then adding the b squared over 4a squared to both sides of the equation. So now everything is fine. Notice that I can combine these two together with a common denominator, 4a squared. So this here would have to be a minus 4ac, and then this is still your b squared, no problem, like that. Now we usually like to write this with the b term first. B squared minus 4ac over 4a squared. So now I have my perfect square, so that means this is x plus b over 2a, the quantity squared. Now let's check it. You square the first one, x squared, there it is. Then you take 2 times the cross term, so that would be bx over 2a times 2, so the 2's cancel, and you get bx over a. Then here you have b squared plus, well, over, divided. You have b squared divided by 4a squared. So everything looks good. And now we can take the square root so that x plus b over 2a is, now it's a plus or minus square root, because when you take a square root with a square like that, plus or minus will work. So plus or minus, and here we're going to have the square root of this numerator, b squared minus 4ac, and the denominator, just take the square root. The square root of 4 is 2, and the square root of a squared is a, so the square root of the quantity 4a squared is simply 2a. That's nice, we have a 2a over here. So then we subtract to get x on one side of the equation by itself. So x is equal to minus b. Now notice the 2a is in common to both of these, so I could put minus b plus or minus the square root of b squared minus 4ac, and all of that is divided by the 2a. That's it. That's the quadratic formula. It's not a bad idea to memorize that formula. It shows up so much in physics. Minus b plus or minus the square root of the quantity b squared minus 4ac, all divided by 2a. Notice that sometimes you wind up with one solution. If the b squared minus 4ac, it's called the discriminant, if that is equal to 0, you get one solution. That would be something like with the parabola, if it just touches the axis, say y, and here's your x. So y is your ax squared. This is your ax squared plus bx plus c. That's y, and this is x. But in general, you're going to have something like this, where it's going to cross the x-axis in 2 places. You'll have 2 solutions. Oh, but what about this? Where the parabola doesn't even come down enough to cross the x-axis at all. Well, when that occurs, we look at our general solution, you will find that this discriminant in here, what that's called the discriminant, that becomes negative. So you take a square root of a negative number, like something like this, that's an imaginary number, which we call I. So there are no solutions where x is a value, a real number on the number line. So you basically have three cases. You have the two solution case where you have a point here and a point there. And you then have the one solution case where you just touch like this. And then you have the no solution case. Isn't that neat? And this square root will either be, say, 0, in this case, b squared minus 4ac is equal to 0. In this case, the b squared minus 4ac is greater than 0. So you have a positive value. And then here, the b squared minus 4ac is less than 0. So you do not have a square root that gives you a real number that would be along that line. Very fascinating. Complex numbers are things that I consider a lot in other courses. And here, let's just not worry about them for now and just consider the two cases that are shown below here, these two. Before we go, I'd like to do one specific problem. Suppose we have an equation of the form y is x squared minus 7x plus 7, and I want the solution when y is equal to minus 5. All right, so this would equal then minus 5. If I add 5 to both sides of the equation here on the right side, we would have x squared minus 7x plus 12 equals 0. Now, you might recognize, if you remember your factoring, that we can get the two answers very, very easily. X, and it's always good to try factoring first, but if you don't figure it out by factoring, we'll show you how to do it in a second using our formula, quadratic formula. So here, we need the product of these two to get 12. So you would try 3 and 4 and see if you add them, you would get a 7. And since you have a minus sign, you would put a minus 3 and a minus 4. And here you get x squared, then you have minus 3x, minus 4x is minus 7x, and then a minus 3 times a minus 4 is a plus 12. All right, but say we didn't see that trick. Well, then we look at this equation of the form ax squared plus bx plus c equals 0, where the c is 12, the b is minus 7, and the a is 1. Comparing here, 1 minus 7 and 12. Then the formula is minus b plus or minus the square root b squared minus 4 ac, all divided by 2. So the minus b would be a minus 7, that's a plus 7. And then here we would have the square root of b squared, a minus 7 squared is 49. And then minus 4ac. Well, a is 1 and c is 12. So 4 times 12 is 48, and that would be minus 48, and you would divide by 2. So this is 7 plus or minus the square root of, well, 49 minus 48 is 1. And this would be 7 plus or minus 1 over 2. And if we take the plus sign, you'd have 7 plus 1 over 2, and that would be equal to 4. And if you take the minus sign, you would have 7 minus 1 over 2, and that would be 6 divided by 2 would get you your 3. And there are your two solutions. Your two solutions are 3 and 4, a plus 3 and a plus 4, because this equation would be 0 if x is a plus 3, you get 3 minus 3, 0 would kill it. Or if x is plus 4, that would kill the other one, you would have the solution. So that's a nice little example where our formula is quite general, because here we had a quadratic equation where the y, was minus 5, and we then put it into our form where you have ax squared plus bx plus c, and solved it two ways, by factoring and by the quadratic formula.